Okay, let me go ahead and get started. Let me ask about homework first. Oh, this is, what is it, October 27th, Friday? Questions on the homework? Everybody understands the homework perfectly. I'm glad to hear that. Yes?
What significance level in one step?
Okay, the question is what significance level? We'll do 5% error. Go ahead, ask. Okay. Okay. Let's see. Let's just say our data looks something like this: 120, 130, 115, 112. That's our data. And so, and maybe 101, so we can have a. So we use that formula and we get a shift. All the data's above 100, so we're going to let our shift be equal to 100. Okay. Okay, so that means we're going to transform this data before we do any more analysis on it. Once we have the shift, we're going to transform this data, and instead of this data, we're going to be looking at the blue data. So now we will analyze this data as if it was the raw data. Okay, so that means we'd have to determine if, I think the issue is exponential, we would determine the mean of the blue data and use that in our formula. So the hypothesized formula would be 1 minus, what is it, e to the minus, it's the x value divided by whatever the average is. Right, but it's the average of the blue data. Okay, and that's the way. And then when you get the answer, you'll take whatever that distribution is and say it's if you were to accept that hypothesis, then the distribution would be 100 plus the exponential distribution. Does that kind of clarify it? Or wasn't that your question? The what? Wait, say that once more.
This is gamma, right?
Uh-huh.
So we're going to have to calculate this from the data and then subtract it. So the gamma isn't given, right?
That's correct. Okay. Let me repeat that so everybody can hear that. The formula in the textbook that has gamma is equal to some things. Okay, that's the gamma that you're going to have to calculate. That's that 100. When I said, let's say the shift is 100, I'm assuming that's what we got after we calculated the gamma from that formula. So this is gamma. And then we have to shift all the data, and then we use that shifted data to do our fit. Is that clear? That's okay. Any other questions? Okay. Let me talk about another problem. I have here a spreadsheet. Okay, here's a spreadsheet. Let me show you what I have on the spreadsheet. We have a couple of different projects. What I'm doing right now is testing your statistical intuition. We have a couple different projects. Here's project A. I've simulated it, and I've got 10 data points. Those 10 data points represent hourly profit. There's project B, 10 more data points, and then this is my final answer. I've just stored the averages on this summary spreadsheet. So, what project, and of course we like profit. Which project would you recommend? Can anybody make a recommendation on which project we should use? Project B. Does that seem reasonable? Would anybody like to criticize that suggestion? I'm open to criticism. I'm recommending Project B. You might think about, actually some of you have got your lab back already, and you probably asked Ben why you got some points off from that lab, because you might have been surprised since your statistical intuition wasn't up to par. Now, can anybody criticize the decision of recommending Project B over Project A? I don't have any idea. The statement was replication length wasn't long enough. I have no idea. I can't make any conclusion about this. You don't have enough information to make any recommendation. If you have a statistical number, a number you obtain from a statistical experiment, if you don't have any idea of the variability of that number, you can't make any judgments. Okay? Numbers without statistical numbers without some idea of their variability are useless. Okay? So you can't make any conclusion because you don't know what the confidence intervals are. Okay? You have to know what the variability of an estimator is before you can use it. Okay? And it turns out, if we look at this project, Project A, I'll show you where these numbers actually came from. I better expand that. Can you see in the back? Can you see those numbers were actually gotten by that formula? So what's the average value? 102, right? That's 102. Project B was designed to be 100. So actually Project B's real mean is less than Project A. Okay? But just because of statistical variation, it turns out, actually what I did is I kept hitting that F9 key till I got one above the other in the wrong way so I could illustrate the point. But you just don't know. Statistical variation, you have no idea what the variation is unless you have a confidence interval. Okay? So if you're going to make a recommendation based on a simulation is always a statistical experiment. So you can never make a recommendation without having some idea of the confidence interval, some idea of the variability. And in this particular, basically what you need to do is if you have one value, and let's do it on the real line. That's the real line. If you have some value, you get a confidence interval. You have another value, and you have that confidence interval. That if this x can be anywhere in that confidence interval, the real value might be right here, and the real value for the other one might be right here. So if a quick and dirty way to determine the difference is look at the confidence intervals. If the confidence intervals do not overlap, then you can say they're statistically different. Now we're going to talk about if you're okay. Let's say you have an experiment and your gut feeling is I really think A is better than B, but your confidence intervals overlap. So you can't make the recommendation. What would you do? Say it again. Yes, increase the observations. If the confidence intervals overlap, the only possible if you haven't done any other statistical test, and we'll talk about a paired t-test later on, if that rings any bells from your statistics class. I'm not ready to do that yet. There's other things I want to talk about. If the confidence intervals overlap, the only thing you can say is there's too much statistical variability to determine if there's a difference. Okay? So it might be that you don't see the difference because of the statistical variability, or it might be that you don't see the difference because there is no difference. But you don't know which one yet. So you got to collect more data, which means you do one of two things: make your replication length longer, or have more replications. Both of those things will produce a smaller confidence interval. Okay? So if you have kind of large confidence intervals, if you're the experiment designer and you have kind of large confidence intervals, you can't conclude they're the same. I mean, I've had some people where we've done the simulation, they say, well, confidence interval is too large, I can't tell the difference. No, you design the test. You ought to collect more data. Don't give up now. Get more data till the confidence intervals are relatively small. Okay. Okay. That was with respect to last week's lab, because most people had overlapping confidence intervals and went ahead and made the claim that one was better than the other, when in fact you couldn't. Let's go to one other thing about that lab. Well, maybe my computer is frozen. Now maybe let's try it again. Okay. Okay, what was I going to do? Look at the lab. This is just a shortcut. You may or may not like it. You don't have to. It's just something I would do. If you remember in last week's lab, one of the questions was the cycle time more than 2 hours? Okay. Most people had a decide module, and then you either tallied a 0 or a 1. That's probably the way most people did it. An alternate way to do it, here's another tally. You can see the flow. Okay, wait, let me show you. This is the first option. Arrivals come in, they do the paper process, they go to a stock person. There's a decrease in WIP, then the cycle time. This records whether the cycle time is long or not. If I open that up, you probably can't see this in the back. Let me write this down for you. This piece right here, what that is the following. T now minus start time okay, so that's the cycle time. Okay, greater than 2. Excuse me. So the base time units were in hours. And so what I'm putting in the expression is a Boolean expression. A Boolean expression, this text is like in C programming. A true Boolean expression is evaluated as a 1. A false Boolean expression is evaluated at 0. And so for the expression, I simply put the Boolean expression, so it's always going to be a 0 or a 1. So that's just kind of a nice shortcut when you're collecting Boolean information instead of having a decide module. Okay. I think that's all the background you need for the lab. So if you'll take a minute to read the lab, after you've had a chance to process it, we can talk about it. Okay, I can mention one detail, the Weibull distribution. This is more typically how you give in the Weibull distribution. Very seldom would you be given the shape and scale parameters for the Weibull. So I'm going to suggest you use the Weibull distribution for this, but you'll have to use whatever you did for the homework the other day. Now that you know how to do it, I figure I can use it in the lab. I also have, the spreadsheet I did in class on Wednesday involving the Weibull distribution. That's stored on the G drive, so if you want to pull that up, you can also use that. But you'll need to figure out the shape and scale parameters for the Weibull. I think everything else is okay until you get to it. We'll find out what questions arise as you work through it. Oh, one other thing. On the schedule, you're going to have to use a schedule for this, for both the repairs or shift changes. The routine maintenance is probably easier done with a schedule. But I think the routine maintenance is a half hour. If when you pull up the schedule, there's a little options thing down in the lower left-hand corner, and that's the way you change the axis. I think the default for the axis on the schedule is per hour. But if you go to the options, you can change that default to half-hour intervals or something. Okay, now that you've had 30, 40 minutes to look at the problem, let me ask you a couple questions. What do you have for time zero? What does time zero refer to?
12 p.m.
12 p.m.? Is that midnight or noon? Noon, okay. What's wrong with having time zero midnight? That's where it would normally be.
Zero arrival?
That's correct. Okay, because of the arrival pattern, you cannot let zero refer to midnight. Okay. How many process blocks are you using in your model? 2. Yeah, that's right. There's 2 different types of failures. There's a catastrophic failure. What is the rule you're using on that? Right, we have 3 rules: preempt, wait, ignore. Yes, preempt. Okay, so the catastrophic failure must refer to a preempt. How about the on routine maintenance? You can do it one of 2 ways. You could either do it, in general, not necessarily for this problem, but in general, you can do routine maintenance through a failure module or through a schedule. I can't remember why. It just struck me that a schedule is easier to do it on this one. I'm not sure that's always true. What rule are you using for the... is anybody doing it, the routine maintenance, using the schedule? Resource schedule? No. Is anybody doing routine, or haven't you gotten that far? Are you doing routine maintenance by a failure? Okay, in this particular case, I think the timing is wrong. Failure is going to be kind of difficult. You probably have to do it by a resource schedule. What rule would you use for the routine maintenance?
The same?
Hmm?
The same thing?
Okay, what rule? I had to read it again. I'm sorry. So what rule are you using? Preempt. That's correct. Okay. What rule are you using for the shift change? Wait. No. Ignore. That's good. You got those rules done. That's great. Okay, I think those are all the issues. Have you all come up any other issues? Any questions? Okay, this one looks good then.